So the title of my dissertation is Getting to the Point, First Cosmic Neutrino Source Search with KM3net ARCA detector. Basically what we did is, with a detector that we're building at Earth, named KM3net, we are trying to connect the world of particle physics with the world of astrophysics. KM3net stands for Cubic Kilometer Neutrino Telescope. It's not a regular telescope, but it's a huge network of lines with light sensitive modules. And why light sensitive? Because neutrinos, which are fundamental particles, in principle they can fly through everything. But what can happen, and that's in our case the only way we can make them visible, is once a neutrino hits a water molecule, it produces a charged particle, and when this moves faster than the speed of light in water, it can produce blue light. One property of this neutrino is that it very limited interacts with matter. If we measure it, it means that it exactly points back to the origin where it's created. KM3net is being built. The ARCA part will consist of 230 lines in a cubic kilometer network. But at the moment, the data that I analyzed was with only 6 to 8 lines and approximately 300 days of data. I selected 100 candidate sources that we already know they exist, and we expect from these sources that they emit neutrinos. So for each of the sources, we looked within a 5-degree cone around the source, whether the events that we saw coming from that direction, whether they look like a neutrino signal coming from the source. So for each of these 100 sources, we made up these models, our expectation, and then you look in your data and you check whether the thing that you observe in your data looks more like signal or looks more like background. And in this case, this is really just to locate the sources, and in the future we hope to also learn more about the physics. The current result of my work is basically the red points, including the line. So each point is the result of one of the sources, and on the y-axis it's the flux limit that we can set, and on the x-axis it's the part in the sky that you're looking at. Compared to the result that we had with 6 lines and 92 days, we already improved a lot. We are still an order of magnitude worse than, for example, the Antares detector, which already took 13 years of data in this case. But this detector stopped taking data. We're also not yet close to the IceCube sensitivity. But what is interesting to see is that IceCube, which is also much bigger and already took 7 years of data, but IceCube is very sensitive in half of the sky because it's located at the South Pole. And when the Earth rotates, you always see the same part of the sky. Very limited in sensitivity on the other side of the sky. So once KM3net gets better, it will soon, especially in the southern hemisphere, will probably get better than IceCube in pinpointing the sources. And at the very bottom you can see an expected sensitivity for the KM3net ARCA detector in its full size.